world is a massive assembly line, churning out over 252,000 new cars every day, with major manufacturers like Toyota, Volkswagen, Honda, and Ford leading the charge. But here's something wild. About 27% of these vehicles meet their end annually. But what happens next is a mystery that might surprise you. You see, on average, a car's lifespan hovers around 12 years, though some high-end European models can keep cruising for a few extra laps. The lifespan of these machines varies widely, influenced by factors like climate, maintenance habits, and even the road conditions they face daily. For instance, did you know that cars in Japan are often scrapped after just 7 years due to strict regulations, while in the US, they might be driven for 15 years or more? But what happens when these road warriors retire? Well, stay tuned, because we're lifting the hood on the fascinating journey of cars when they die. And trust me, the final destination is more surprising than you think. Step 1. Collection and transport. When a car reaches the end of its life, whether it's due to age, an accident, or just no longer being roadworthy, it typically ends up in a scrapyard or recycling center. Now, you might think it's a simple matter of towing the vehicle there, but it's actually part of a larger network. Around 14 million vehicles in the US alone are retired each year, and their journey begins with collection and transport to authorized dismantlers or shredders. The collection process involves more than just picking up a car. Specialized companies handle this, and they need to ensure that the vehicles are securely transported to avoid any potential environmental hazards, such as leaking fluids. These vehicles are typically loaded onto flatbed trucks or towed to the recycling facility. During this phase, it's also important to note that cars are assessed for any reusable parts before being recycled. This means that in some cases, parts may be removed and sold before the car even reaches the shredder. In fact, according to recent data, nearly 86% of a vehicle's material content can be recycled, and about 80% of a car's weight is recycled, which makes the whole process not just environmentally friendly, but also economically viable. Step 2. Drain and detach. Once the car arrives at the recycling facility, the real work begins. The first order of business is draining all the fluids from the vehicle. Cars contain various hazardous materials that, if not properly managed, could pose serious environmental risks. We're talking about fluids like oil, gasoline, brake fluid, transmission fluid, and even coolant. These substances need to be carefully extracted and either recycled or disposed of following environmental regulations. It's not just about fluids, though. Cars also contain other potentially hazardous materials such as batteries, airbags, and mercury switches. Modern cars, with their advanced electronics and safety features, often have a lot of these components. For instance, airbags contain explosive materials that need to be handled carefully, and the lead-acid batteries found in most vehicles can be extremely toxic if not properly recycled. Facilities have specialized equipment for this stage, including fluid evacuation systems and safety measures for dealing with explosive or hazardous components. It's a meticulous process, but a necessary one. According to the Automotive Recyclers Association, over 95% of car batteries are recycled, indicating how seriously the industry takes this part of the process. The removal and proper handling of these materials ensure that when the car moves on to the next stage, it's safe to do so. Step 3. Dismantling and sorting. After all the hazardous materials and fluids have been removed, the car undergoes dismantling. Every car is made up of thousands of components, many of which can be reused or recycled. During the dismantling process, workers carefully remove valuable parts such as engines, transmissions, doors, windows, and other components like seats and electronics. This step is where the true value of car recycling becomes apparent. Many of the parts removed during dismantling can be refurbished and sold as used parts. In fact, the used auto parts market is a billion-dollar industry, driven by the demand for affordable replacements. For instance, engines and transmissions can fetch a good price when sold to repair shops or car owners looking for cost-effective repairs. However, not all parts are destined for reuse. Components that can't be resold or refurbished are sorted into different categories based on the material: metal, plastic, glass, etc. This sorting is vital for the next stages of the recycling process, ensuring that materials are properly processed and reintroduced into the manufacturing cycle. Step 4. Shredding. Once the car is stripped of its valuable and reusable parts, what's left is typically a shell of metal, plastic, and glass. This is where the shredding process comes into play. Specialized machinery known as shredders are used to crush the car into smaller, more manageable pieces. The shredders can reduce a vehicle to fist-sized chunks within minutes, making it easier to sort the recycling materials. The metal, which makes up about 75% of a typical car's weight, is the primary focus during this stage. The shredded material is then passed through magnetic separators to extract ferrous metals like steel and iron. These metals are highly recyclable and are often sold to steel mills, where they are melted down and reused in manufacturing new products, including new vehicles. But it's not just about the metal. Non-metallic materials, known as automotive shredder residue, are also produced during shredding. This includes plastics, glass, rubber, and textiles. Advancements in recycling technology have made it possible to recover even some of these materials, reducing the amount of waste that ends up in landfills. Step 5. Material sorting. After shredding, the mixture of materials needs to be carefully sorted because different materials require different recycling methods. In this stage, technologies like magnetic separation, eddy currents, and air classification are employed to separate ferrous metals, non-ferrous metals, and non-metallic materials. Magnetic separation is used first to pull out ferrous metals, such as steel and iron, from the shredded material. These metals are then sent to steel mills for further processing. Next, eddy current separators are used to extract non-ferrous metals like aluminum and copper, which are valuable commodities in the recycling market. These metals are also sent to specialized facilities where they are melted down and reformed into new products. The remaining material, often referred to as fluff, consists of non-metallic components like plastics, foam, and textiles. Advanced sorting techniques, including air classification and density separation, help to recover these materials. Although recycling plastics and other non-metals from cars is more challenging, ongoing innovations in material recovery are improving the efficiency of this process. For example, certain types of plastic can be chemically broken down and reused in new automotive parts or other products. Step 6. Processing and purification. Once the metals have been separated, they are sent to processing facilities where they are melted down and purified. Steel and iron, which are the most common materials recovered from cars, are typically sent to steel mills. Here, the shredded metal is melted in large furnaces at temperatures reaching over 1500 degrees Celsius. The molten metal is then poured into molds to form new steel products. The melting process isn't just about recycling, it's also about refining. Impurities and non-metallic inclusions are removed during melting, resulting in high-quality steel and iron that can be used to manufacture new products. This step ensures that recycled metals meet the stringent quality standards required by industries such as automotive manufacturing. Aluminum, another common metal found in cars, undergoes a similar process. However, aluminum recycling is slightly different because it has a lower melting point than steel, making the process more energy efficient. In fact, recycling aluminum saves up to 95% of the energy required to produce it from raw materials, according to the Aluminum Association. Step 7. Creating new products. After the metals are melted and purified, they are ready to be reformed into new products. This is where the true magic of recycling happens, turning what was once an old, unusable car into something entirely new. The recycled steel, aluminum, and other metals are cast into new shapes, such as steel beams, aluminum sheets, or even new automotive parts. These materials re-enter the manufacturing supply chain, ready to be used in the production of everything from new cars to household appliances. But it's not just about metals. Plastics recovered during the recycling process can also be reformed and reused. For instance, certain types of plastic are processed into pellets that serve as raw material for manufacturing new plastic products, dashboards, or durable bumpers in the next generation of cars. Similarly, glass from windows and windshields can be crushed and recycled into new glass products such as fiberglass insulation. Step 8. Closing the loop. Recycling cars play a significant role in reducing the environmental footprint of the automotive industry. According to recent data, recycling a single car can save up to 1.25 tons of iron ore, 0.7 tons of coal, and 62% of the energy required to make new steel from raw materials. Economically, the car recycling industry is a powerhouse. In the U.S., it generates over $25 billion annually and provides jobs to around 100,000 people. Moreover, recycled materials contribute to cost savings in various manufacturing industries, making products more affordable for consumers. The process doesn't just benefit manufacturers, it also helps consumers. By purchasing recycled auto parts, consumers can save up to 50% compared to buying new parts. This affordability helps keep older vehicles on the road longer, reducing the need for manufacturing new cars, which in turn conserves natural resources. Environmental benefits extend beyond resource conservation. Car recycling also significantly reduces greenhouse gas emissions. For instance, recycling steel from cars results in a 58% reduction in CO2 emissions compared to producing steel from iron ore. This reduction is equivalent to taking millions of cars off the road in terms of emissions saved. But the impact doesn't stop there. The energy saved through car recycling is also substantial. Recycling aluminum, for example, uses only 5% of the energy required to produce new aluminum from bauxite ore. This energy saving is crucial in a world where energy resources are increasingly strained.